Hi, this is Daryl. Welcome to the 10.09 VXLAN Enhancements overview session. I will be covering the following VXLAN enhancements in 10.09: Multicast VXLAN, VSX Active Forwarding support for VXLAN underlay, VXLAN policy-based routing, EVPN VXLAN multi-fabric, EVPN route map, VXLAN PVLAN, and finally supporting the same SVI active gateway IP on distributed layer 3 gateways. Let's cover Multicast VXLAN next. In 10.8, your VSX Border VTEP connecting to the external or non-overlay network could only connect to sources, multicast sources. But in 10.9, we now add support for the VSX Border VTEP to connect to both sources and receivers in the non-overlay network. And the supported platforms are the 6300, 6400, A325, A360, 8400, and the CX 10.000. Multicast VXLAN only supports IPv4 today, so that's why you can see in this picture the receiver only has an IPv4 address. This capability only supports IPv4 as well. This capability requires a new CLI. You can see IP-PIM sparse data path auto include. This is required on the transit SVI between the ISL on VSX switches. This will allow the VSX switches to be in the same multicast data path state. So I have a border VTEP 1A on the left, border VTEP 1B on the right, and I have interface VLAN 1500. This is the SVI that's only used between the two VSX switches. I attach them to the VRF, and I have an IP subnet, a /30 IP subnet that's only used between them. I enable OSPF and IP-PIM sparse. I also add the new CLI, IP-PIM sparse data path auto include there. So this is only for VRF1. If you have other VRFs like VRF2, you need to create additional /30s, and each one will need to have this new CLI required. Let's move on to VSX Active Forwarding, support the VXLAN underlay. In the past, you had to use routed-only ports as uplinks on your VSX VTEPs. So 10.9 adds support for VSX lags to be used as uplinks into the underlay network. You can see this picture, the bottom VSX VTEP, he has VSX lags as uplinks into the underlay. So with this new capability, you need to add in the VSX Active Forwarding on your SVI uplinks. I have this example 1A and 1B VTEPs. SVI 1500 is the uplink VLAN to your underlay. You need to add on the VSX Active Forwarding keyword onto that SVI. And this is support on the VSX VTEPs such as 6400, A325, A360, 8400, and the CX 10.000. VXLAN PBR. 10.9 also adds support for VXLAN policy-based routing. What does that mean? In this example, you see that traffic normally uses the default route on switch 3 on the right. So I have a VTEP that is switch 2. I have SVI as the default gateway. If that host, the 1.21 host, tries to send traffic, it will normally be routed towards the default route on the right. Let's say you wanted to change the next hop. Instead of using the right path, I want to use the left path towards the firewall. That's possible with policy-based routing. You want to overwrite the default route. So you apply inbound policy on the interface VLAN 20, specify the next hop of the firewall, which is 1.2. So this is really used on layer 3 VTEPs to redirect traffic to the desired next hop IP over an L2 VNI. Take note, these policies are unidirectional and they apply inbound on an SVI. So if traffic from 1.21 hits the firewall on the left, goes out, is being netted to the 1.2 IP on the top, the return path will automatically send back to that netted IP. But if it's not netted, then you will need another PBR policy on the north to south direction because it's unidirectional. So the supported platforms are H25, H360, and CX 10.000. VXLAN PBR can be used with distributed layer 3 gateways. This is an example, very similar to the first example before. I have switch 2 and switch 3, which are distributed gateways with the same IP, the 1.1 on both, and I have hosts 1.21 and 1.22 that are connected to both VTEPs. So traffic is normally using the normal route on the right to get out to the destination at the top. But let's say you wanted to change the next hop, that's possible. Instead of using the right, you want to use the left. So you could have a policy apply inbound on the interface VLAN 20 or both switch 2 and switch 3. You wanted to redirect traffic, TCP traffic, destination port 5004 to the next hop of 1.250. So you can see that IP is on the same subnet as your default gateway because it's L2, has to be on the same subnet. So you could apply that policy for that specific traffic, the TCP traffic, to use the left path. All other traffic will use the right on the switch tree to get to the destination. You could also use VXLAN PBR for centralized layer 3 gateways. In this example, I have switch 1, VTEP 1 is a centralized layer 3 gateway. It has the default gateway IP of 1.1. I have switch 2 and switch 3, which are just pure L2 VTEPs. And you could have a policy on a centralized layer 3 gateway that's connected to a firewall or IPS at the top. You could redirect that. For example, in this case, I want to apply a policy on interface VLAN 20 of that switch 1. I want to redirect only UDP traffic from both sources, 1.21, 1.22, to the firewall next hop IP of 1.2. So that's possible. All other traffic should continue to use the default route towards the destination and not towards the firewall. So you could be specific to redirect only the UDP traffic from those specific sources in this case. EVPN VXLAN multi-fabric. 10.9 ends support for EVPN VXLAN multi-fabric. This can be on a single VXLAN fabric limit. On the picture on the left, you can see a campus that might be split across 2 zones or data centers that are split across 2 sites. But we only supported a single VXLAN fabric before this 10.9. That means we have full mesh VXLAN tunnels between all VTEPs and a single hop because it's full mesh. And you do have a fabric limit of 256 BGP EVPN peers per fabric. And now in 10.9, we can actually do multi-fabric. That means you could have a campus, a large campus that's split into 2 zones, and each zone, campus zone, or each data center or each site is considered its own fabric. I have a fabric 1 on the left, fabric 2 on the right, and they're interconnected only at the border VTEPs with an external tunnel. You can see it's still full mesh within that one fabric, but between the fabrics, we have a single tunnel connecting them together via the VTEPs. This is a technology that's applicable to both campus and data center VXLAN deployments, but refer to the caveat section for more details. Supported platforms H25, H360, and CX 10.000 will support this multi-fabric solution. Right? It's only really required on the border VTEP. The other VTEPs, you can see that do not connect to other fabrics. Those could be normal VTEPs such as 6300, 6400. With this capability, you now have improved VTEP scale. So it's per fabric up to 256 BGP EVPN peers. And it's considered multi-hop because you're actually doing tunnel-to-tunnel forwarding from one VTEP, it goes to a border. The border VTEP will do tunnel-to-tunnel forwarding of the traffic instead of full mesh. EVPN route map. 10.9 supports EVPN route maps for VXLAN deployments. This will allow a VTEP to apply a inbound or outbound route map to a BGP peer under the EVPN address family context. These are the different match conditions that are applicable: IPv4, IPv6 address prefix list, AS path list, layer 2 and layer 3 VNIs, while the set clauses are local preference, AS path prepend, exclude, and IP next hop. This example, I show you two fabrics and a border VTEP 1 and border VTEP 2 that are connected to the AS65100 at the top. So the objective is for border VTEP 2 to be used as the preferred outbound VTEP over border VTEP 1 for routes going towards that AS number at the top. So you could do this by setting a higher local preference for EVPN routes learned on the second border VTEP from AS65100, and on the VTEP 1 you set lower local preference for those routes. That way all VTEPs would use border VTEP 2 to get out towards 65100. And more importantly, EVPN route maps are required by multi-fabric VXLAN when there are multiple ports or AS numbers within each data center or site. VXLAN PVLAN. VXLAN PVLAN or private VLAN provides L2 segmentation. Take note, it's only for IPv4, IPv6 unicast traffic only between desired hosts on the same subnet. So you can see here, hosts within the same community VLAN will have network connectivity like the blue ones. So 1.21 can communicate with 1.23, but we have also hosts that are on the isolated VLAN, the red one. So 1.31 cannot communicate with 1.33 or hosts in the other community VLANs. But all hosts will be able to reach their default gateway in the primary VLAN. So the primary VLAN is the green one, and that's applied on the SVI. So that's the default gateway, so everyone can reach a default gateway, but they can be isolated if desired by placing them to isolated VLANs. But if hosts should communicate, they can be placed in the same community VLAN. These are the supported platforms: 63, 64, H25, H360, 8400, and CX 10.09. Supporting the same SVI and Active Gateway IP on distributed layer 3 gateways. Before 10.9, you could use the same Active Gateway IP on every VTEP for distributed gateways. You can see the 1.1 is on every VTEP here, but a unique SVI IP is required on every VTEP. So you can see VTEP have 1.2, 1.4, 1.6, 1.8. Those are the unique IPs, physical IPs on the SVI. In an upcoming 10.9 CPE, you will be able to use the same SVI IP on every VTEP. So this example, you can see I have 1.1 as the active gateway IP and the physical IP address on the SVI. You can use that on all your VTEPs, your distributed layer 3 gateway VTEPs, so that you do not need to burn additional IPs. That's applicable for IPv4 unicast multicast traffic, IPv6 unicast traffic, because IPv6 multicast is not supported in the overlay, and for VSX or VSF VTEPs. These are the platforms below: 63, 64, 8325, 8360, 8400, and the CX 10.000 that will support the same SVI IP and Active Gateway IP.